So my name is Lisa Barnes, and I am a cognitive neuropsychologist and a professor at Rush University Medical Center. I'm also the associate director of the Rush Alzheimer's Disease Research Center and a former director of a Center of Excellence on Disparities in HIV and Aging, which is why I'm here. And I want to thank the organizers. This seems like it's been a really great two-day meeting. So much love in this room. Thank you all. Thank you. Okay, great. So let me see, how do I work it though? This way? Yes, okay. So, I have until 2:15, so I want this to be informal, and I want you to ask questions throughout, so don't wait till the end. And if I go, too fast or something's not clear, just holler. So Gary Sellers is the one who invited me, and when he reached out, I told him that, well, I haven't been working in the HIV and aging space for a few years because our center ended, but I would look in the literature and see, what's been done since we stopped our funding. And I was surprised to see that not a lot has been done on HIV and aging as related to brain health since we lost our funding. And the reason that I really wanted to get into this area is because, HIV is now considered a chronic disease of aging, right? It's no longer a death sentence, as you can see in this room. And so I really wanted to try to understand, what is happening as people age with this disease. And so we talk about being in the fourth decade of the HIV epidemic now. Because of how well the medications work, the number of people, older adults living with HIV is really increasing. So this slide is data from the CDC from 2023, the last time that the data were released. And of course now the world's on fire, the CDC, we don't know what's going on with the CDC, but what you can see are the rates of HIV diagnoses among people aged 55 and older by different characteristics. And so we can see that in this age, sorry, I want the pointer. Is this the pointer? We don't have a pointer? Okay, well, that one is the off button. Okay, right. All right, so you can see that males have the bigger rate of HIV diagnosis in this age group. People between the ages of 55 and 59 have the biggest rate. And then we look at race, ethnicity, Black African Americans have the biggest rate, and people living in the South have the biggest rate. If you look at the Midwest, it's actually the lowest rate of all the different regions. But by 2030, we estimate that more than 70% of adults with HIV will be over the age of 50. And the disparity is even greater if you are Black American. Black Americans face the most severe burden of HIV. In 2018, Black Americans represented only 13% of the US population, but 41% of people living with HIV, and 43% of all new HIV diagnoses. So it's a tremendous health disparity for Black population. And in fact, HIV/AIDS is the fourth leading health disparity for Black people. You can see the different types of disparities on the screen. I mean, it's no surprise, everything affects us as Black people, but breast cancer is more, diabetes, heart disease, obesity, and HIV. People who are Black are 9 times more likely to have HIV. So what I want to talk about in my time is what is brain health, and talk about the CEDA study that we ran, which was the study that came out of our Center of Excellence, and just give you a few selected results of some of the things we looked at, and then end with prevention strategies that we can all use to protect our brain health. So this is the brain inside of our head. We all have one. And, it's only about 3 pounds in the adult, an average of 3 pounds in the adult human brain, adult human. But it's the most complicated and important organ in our entire body. So when we talk about brain health, what do we mean? Brain health refers to how well a person's brain functions in different areas. And so this graphic shows you all the different areas. You can think about motor function, your ability to move and walk and have balance, so you don't fall. Your brain controls that. Sensory function, everything that you can see, hear, taste, smell, all those functions are controlled by your brain. Tactile function, the ability to feel and respond to sensations of touch, including pressure, pain, and temperature, which is important for safety, obviously, right? Because you don't want to touch a hot stove and keep your hand there. You need your brain to get the signal that this is hot, and you lift your hand up. Emotional function, which is interpreting and responding to emotions. And then the most important for me as a neuropsychologist is cognitive function or cognitive health. And that's thinking, learning, and remembering. We take all of these things for granted when they're going good, right? But as soon as you start to lose something, that's when it's a problem. And we want to have optimal brain health as we age. But I think the most scary thing for people as they get older is the loss of cognitive function. And who knows what happens when you have loss of cognitive function? What's one condition? Dementia, Alzheimer's, right? So dementia, that is an umbrella term that's used to describe a range of different symptoms associated with cognitive impairment. And underneath the umbrella are all the different reasons you can have dementia. Alzheimer's disease is the most common cause of dementia, but you can get dementia for many other reasons. You can have stroke, have a vascular dementia, Lewy body, or frontal temporal. You probably heard about Bruce Willis. He now has frontal temporal dementia, which is problems with language, which is terrible for an actor, right? Yes, sorry. Lewy body is a type of dementia that where you have problems with movement and hallucinations. It's a very bad dementia. I mean, all of them are bad, but Lewy body dementia seems to come on more rapidly, and I think more behavioral problems with dementia. With the condition. Whereas Alzheimer's, we always hear about Alzheimer's because it's more associated with memory loss. Good question. So, when we start thinking about HIV and aging, we're now in new territory because people weren't supposed to live, until 50, 60, 70, because, in the early 1980s, it really was a death sentence. But now, as you can see, people are surviving, people are thriving. But science has to catch up with you all, right? So there's so many things we still don't understand. Like, what's the effect of the therapeutics on the body? What is the effects of physical and social functions as we age? What about social isolation and loneliness? We know there's a loneliness epidemic in the general population. How does it affect people with HIV? These are questions we still need to understand. We need to be able to train caregivers and social service professionals to work with the population. Then there's stigma associated with the disease itself, but also ageism. People discriminate against people because they're just older. Now you put that together with HIV, you have a double whammy. And then there's multiple comorbidities and polypharmacy. We don't understand how those interact. And then lastly, neurocognitive impairment. So why should we be concerned about HIV in older people, at least from a brain health perspective? Well, we know that there's lots of aging-related conditions, like I just told you, like hypertension, diabetes, what else? Thyroid, dysfunction. All these things can complicate the management of HIV infection. But also, HIV may affect the biology of aging itself. Our bodies are changing as we age, anyway. And then you put an infection on top of it, that's going to interact with the biology of aging. And then we have reduced immunological defenses and change in risk behaviors that could lead to increased risk of acquisition and or transmission. And then finally, screening for the infection is often lower in the older population because of perceived lower risk. Physicians, medical care professionals think that older people aren't having sex. Right, still. We know that is a bull crap, right? But unfortunately, it's still pervasive out there. So screening for infection is much lower in older adults than it should be. So the question is, for me, is HIV a model of accelerated aging, right? Can we really use it to understand how people are aging? So if you think about it, there's many chronic conditions that happen just with aging, like cardiovascular disease, cancer, osteoporosis. So if you look at the lines up here, so the red lines is the HIV population, and the blue line is the general population. So we want to know, is HIV making these chronic conditions happen earlier in life? Or is it just that you're getting more of these conditions because of the infection? Which of these is happening in HIV? That's the question. I do need to talk about neurocognitive impairment in HIV because it's changed over the years. It used to be that we thought that people automatically got dementia from HIV. We now know that that's not true. So we have something called HAND, which is HIV-associated neurocognitive dysfunction. Long word, right? So we say HAND for short. And it refers to a spectrum of neurocognitive impairments, from asymptomatic to mild impairment to HIV-associated dementia. We know that the prevalence of HAND varies widely depending on where you measure it. Yes? Oh, it's too loud? No. Oh, okay. I'm sorry. Go ahead.
Hey, thank you, Doctor. The longer, as your T cells go down, is this more likely to happen? Remember opportunistic infections? Do they consider this one of them? Like when you get below 200?
Yeah, they do, but when it comes to studying the brain, I'm focused on people who are already virologically suppressed, okay? But there is a body of research that looks at that as well, and it's very important. Okay, so the questions that we're still trying to understand is HAND progressive, in this post-CART era? Is your memory getting worse even though you're getting medication? And how do we distinguish HIV effects on cognition just from normal aging effects? Because we all know as we get older, we're gonna lose, no, that's a lie. We're not gonna lose our memory, but we are gonna see some changes in our memories, right? Like you're not gonna remember everything the way you used to when you were like 15, 20, right? How many people are like, they get up in the morning like, where are my keys? Or where did I, when do I have this appointment? Or even, what's this person's name standing right in front of me? Those are all associated with normal aging. So we want to know, can we distinguish that normal aging from HIV effects on aging? That's the question we're after. So let me talk about how I designed the study. Yes, Sanford?
We have a question.
Yes, I wanted to ask, what effect does the long-term use of medication have on us?
That's what we're trying to understand. That's a great question, and we need more data to understand what are the effects of long-term medication. So this is how we designed the study. At Rush, we have two. Yes.
Wait a minute.
That's good. Okay,
so
stop.
I'm thinking, as far as aging, one thing that comes to mind is that a lot of times we see, I feel like we see less cognitive functioning or less quality cognitive functioning recently because of the use of technology. Mm-hmm. Is there any idea if possibly like the use of cell phones constantly and things like that are at the root of this along with some of those other causes?
That's a great point. We always think that technology is supposed to help us, but you're right. Especially if we become dependent on it, is it hurting us? I don't know the answer to that. I don't study that, but I think that's a great question.
Dr. Barnes, we have one more question.
Uh-huh.
Is it sort of like exercise? Because I know that with the AI and the advancements they're making with these phones, you might lose a memory of your passwords and so forth, and if you're not actually doing it, you press the button, expect it to be there, then you don't know.
Yeah, are you saying, is that like an analogy for
Loss of
losing your memory?
Loss of memory.
Yeah, it's like that. You can think of your brain like a computer, right? And your brain has all this information in it, but if you don't use it enough, and do things to keep your brain healthy, you are going to lose information from it. So yes, a great analogy. Keep the questions coming. So I want to tell you about how we designed the study. So we have a study two studies at Rush of older adults who are 65 and older without HIV. We've been following them for 20 plus years, about 3,000 people. They all enroll in the study without dementia when they first come into the study, and then we follow them over time. They all agree to being seen every single year. We do a clinical evaluation. We look for a bunch of risk factors. We give a memory battery, and we take blood. The two studies are called MARS and MAP. So this is important. MARS is completely African American, and MAP is about 90% non-Latino white American. Okay, so these studies have been going on for some time. This is what it looks like. We have a bunch of people, we enroll them without dementia, we measure a bunch of risk factors, then we measure their memory and thinking every single year, we follow them up, and then some people either pass away or they drop out of the study, and the people who are left, we're able to see how the risk factors associate with their memory performance, okay? So that's MAP and MARS. So I wanted to understand, is HIV and aging contributing to loss of cognition in older people, right? And so some of the things we've been talking about is race, lifestyle factors, social factors, trauma. There's the virus itself and inflammation, then there's the medication. All these things combine. Can we figure out how all these things together are affecting people as they age with HIV? So what did I do? I recruited another sample of older adults, some who were aging with HIV, who were 50 and over, and some who were aging without HIV, who came from the same communities and neighborhoods. And then I compared them to my older MAP and MARS people who were 15, 20 years older, right? So I'm trying to see if people who are in their 50s who have HIV, do they look like my 15 to 20-year older people who I've been following for 20 years? That was the basis of what we were doing.
Dr. Barnes,
Yes.
what struck me with what you said was that you had a study that was 90% Black or African American. Did I hear it?
It was 100% African American, MARS.
Tell me, please, how was it that your team was able to recruit these people of African descent when people say, we just can't find them?
Right, good question. Well, we had to actually be in the community, because most research studies, what do? They put a flyer up in the clinic with a poster, come be in my study. But a lot of times, we as Black people have a fractured relationship with the medical care system because we have been mistreated. We all know the history, right? And so we may not show up to a clinic. So our team went into the community to meet people and tell them about brain health and then recruit from the community. And I also, before I got the grant to do this work, I worked in the community doing, memory screens, giving presentations, hosting meetings, just giving first before I asked anything. And then when I got the grant funded, I was able to get 200 people enrolled in the first year because they knew me and they felt like, they trusted me. And I was asking questions that I thought were important as a Black woman, about Black people. So I think all those things make a difference, and it really helped in our success. And it's been going on now for 20 years.
Thank you so very much. We've got one more question, and we're
Yes.
going to let you go forward.
In 2021, this question has been bothering me. And since 2021, when the Swedish woman won the Nobel Prize for genetic engineering, does Alzheimer have a possible fix through genetic engineering?
No, we're still trying to understand Alzheimer's. There is a genetic component, but it's much more complicated than genetics. There's a big environmental piece too. So it's a mixture. It's some of your genes, but it doesn't mean that if your mom had it, you're gonna have it. So it's not, a direct relationship, but a big part of it is the environment. What you're eating, what you're doing, your lifestyle, like, your purpose in life, those kinds of things matter for Alzheimer's. Yep.
Okay, I have a question. My thing with the Alzheimer's, maybe I'm not really sure, but it's like this plaque or something that's like on certain parts of your brain.
Yeah.
And over time, it gets thicker and your brain shrinks or something like that, like the plaque overtakes
Right,
that part of your brain.
So what's happening is the hallmark features of Alzheimer's are these two abnormal proteins called plaques and tangles. We call them amyloid and tau, right? It's two different proteins. But we know that there's other pathologies, other abnormal proteins building up in your brain that is causing Alzheimer's. But these two tau and amyloid plaques and tangles, they accumulate, and then eventually they start to kill the brain cells in your brain. So your brain does start to shrink, or what we say atrophy, over time. But it takes many years. So that's what's happening in your brain. But then what you see in the behavior is that people have memory loss. They eventually forget how to do even basic things like eat and swallow, because they're losing the brain cells. Like I told you in the earlier slide, your brain controls everything we do. So imagine you have these plaques and tangles in your brain, eventually taking over all the different brain cells. Yep, more questions. Sanford, you
Hold
are
on.
such a great, what's that called? Like a moderator.
Moving all around. So you said basically that it's a mixture of the genetics and environment. Are you basically saying that it's kind of like epigenetics and certain environmental factors switch them on and off and cause the issue, and
Yeah.
you're still trying to figure that out?
Exactly. Thank you. Another question?
My mom had dementia, so is it hereditary?
So it's not hereditary in the way that you think. So there's something called Huntington's disease, whereas if you have that genetic marker, you're definitely going to get Huntington's. Alzheimer's does not work like that. So there's something called, there's polymorphism, which are just genes that increase your risk. So the biggest one we talk about is the apolipoprotein E, which shortened is ApoE. If you go to the doctor, you might ask them, do I have the E4 allele? That particular polymorphism increases your risk, but it doesn't mean you're definitely going to get Alzheimer's. So the short answer is it's not genetic in the way you're thinking.
You opened up the door for questions. We're going to do
Fine.
these two.
I'm
so
not
you
going to
can
get
go
through
your
my
next
presentation, so that's good.
Okay, just real short. What you just described, that ALP.
ApoE.
Okay, isn't it a blood test where they check for that?
Oh yeah, now this is a can of worms. So you can get your ApoE from like 23andMe. There is a blood test now, but the problem is because it's a genetic marker, it means it's not actionable. You can't do anything if you have the E4. You can't change your genes, right? So there's a camp of people who are saying that we should not be giving those out because you can't do anything about it. But some people feel like, well, if I know I have the gene, that's going to help me plan for the future, right? But the problem is it's not, just because you have the E4 doesn't mean you're going to automatically get the disease, right? It just increases your risk. Just like if you smoke cigarettes, it doesn't mean you're going to automatically get cancer. You're going to have an increased risk for cancer, right? So it's sort of like that. So I would not recommend that you get the test for the ApoE, because there's really nothing you can do about it at this point.
Last
Yes.
question, and you're going to get to go through your slides.
Okay.
So during a few slides earlier, you had some collective data about the population that you were serving. Out of those particular numbers that you were given, were there any trans numbers included in those particular things, or were they included with the?
That's a great question.
Were they included females?
Great question. When we, that study, that's talking about the CDC slide, they did not include trans in their numbers. I think those were cisgender male and females. But that's a great question, and trans people are invisible to these data, right? That's a real problem. I actually have a mentee right now who is doing a project on trans older adults, and you would be surprised the number of studies that are out there. He can't find anything. So he's creating his own study to understand how trans people are aging, with or without HIV. But it's really an open area of investigation. Thank you for that question. Okay, I'm gonna just run through these really quickly. So I wanted to just show you the sample that we collected. We had 177 people with HIV and 194 without HIV. They were about the same age. It was mostly male, about 13 years of education, mostly black, because that reflects what's in Chicago, people who are infected with HIV. And you can see the other characteristics. You can also see that people had HIV for about 17 years on average, and had been on combination therapy for about 15 years. This just shows you some of the differences between those with HIV and those without, and I just put in red the ones that I thought were really interesting. You know, there was a really high history of smoking. This is compared to our MARS and MAP cohort, who are 15, 20 years older. The history of cancer was much higher in people aging with HIV, as was hypertension and thyroid condition. What was really interesting was depressive symptoms. It was really low in our older people without HIV, but in both the people who had HIV and those who didn't, depressive symptoms were really high. This was measured on a 9-item scale. We usually only see people, endorsing 1 item. And so 2 doesn't seem like a lot, but when you compare it to our older adults, it was a lot. We also asked about trauma and events that were common in people's lives. And I highlighted in red again the things that stuck out that were different from our older adults. So about 55% had never had a credit card, 65% never owned a home, 56% witnessed or were a victim of violence, about 74% were currently unemployed, about half had been to prison, and about 87% had a history of past drug abuse. And you can see the different types of drugs there. Now, this is different from our older adults who are 65, 75, 80. We're going to like churches and senior buildings to recruit those people. For our HIV sample, we recruited from the Core Center, which is, I don't know if you guys are familiar with it. It's a partnership between Cook County and Rush, and then the communities around those areas. I'm gonna skip this. I wanna just go through, we wanted to know, does duration of HIV affect neurocognition? And we found that the longer you had HIV, the worse your cognitive function in this sample. And this duration effect was stronger in black adults with HIV than it was in white adults. But it was only for working memory. Working memory is a type of memory where you have to remember something for a short amount of time, like a phone number, holding a number in your head. So black adults with HIV, the longer they had HIV, had impairments in working memory. We looked at things like loneliness. We found that black adults with HIV reported less loneliness than white older adults with HIV. but we did find that when people had it, more loneliness was associated with lower cognition. So being lonely is a risk factor for losing your thinking skills. We also looked at cognitive activity, which is how frequently you do things like read books, play crossword puzzles. We found that that was associated with better cognitive function, and that effect was stronger in Black adults with HIV. I'm going to skip these and go to the summary. So what did we learn? We learned a lot of things. First, that we were able to recruit a cohort of people aging with HIV and a matched sample of people aging without HIV. We were able to compare them to adults 15 to 20 years older who didn't have HIV, and we found that some factors were higher in the young HIV cohort, things like smoking, cancer, hypertension, and depressive symptoms. We also saw there was a high level of trauma and stressful events in the HIV cohort. And then within CEDA, we found a lot of racial differences between Blacks and whites with HIV. Cognitive activity was stronger in Black adults. Loneliness with the effect of cognition was stronger. And I didn't talk about pulmonary function, but that seemed to be weaker in Black adults with HIV. So in the last 15 minutes, I want to talk to how we can prevent the loss of thinking and memory skills. Because I think that's something that we want to be able to say that, not only are we living with HIV, but we're thriving with HIV, right? So how do we slow cognitive decline or ultimately prevent it? Are there factors that we can be doing in our life right now to maintain a healthy brain? That's the question that I think we should all be thinking about. So I told you that in one of the studies we did look at cognitive activity. So how many people engage in cognitive activity? Reading books, crossword puzzles, even playing board games and cards. Anything that uses your brain is a cognitive activity. And we found that people who keep your brain active by doing these things, you are able to prevent either Alzheimer's and dementia or slow the progression of cognitive decline. So try to do these kinds of things if you can on a daily basis. I know that there's no magazines, now we just do everything on the internet or the phone, but it is good to try to keep reading and doing these kinds of fun things, learning a new recipe even, or taking a class, learning a new language. All these things are cognitive activities. Also, we found that people who are more socially active, we asked people, like, how often do you go, to plays or concerts or hang out with friends? People who did more of that had a healthier brain. So try to remain socially active. And we know that social isolation is a risk factor for Alzheimer's. So if you want to be able to, keep Alzheimer's at bay, try to be socially active, volunteer, be in different groups. We also found that physical activity is good for your brain. And this probably is because anything that's good for your heart is also good for your brain. Because we know that physical activity is related to a lower rate of cardiovascular disease, diabetes, obesity, and all these things. All those things also help your brain stay healthy. So try to be physically active. And a lot of times we see that, as people get older, they become less physically active. And you don't have to join a gym. Just simple walking, 15 minutes a day is physical activity, and that seems to help. Also, you probably have heard a lot about diet. We had a great lunch today. Some of it was healthy, some was a little bit less healthy, but eating a healthy diet is good for your brain. We created a diet at Rush called the Mind Diet, and it really emphasizes foods that are good for your brain, like blueberries, fish, reducing sugar and trans fats. Those kinds of things help your brain stay healthy. And getting a good night's sleep. People always ask, well, how much sleep, do I need? It's not really about the number, it's really quality over quantity, right? And everybody's different. Some people can get by with just 6 hours, some might need 9 hours. But really you want to be getting good quality sleep and having really good sleep hygiene. So that means don't go to sleep with the TV on, like my mother sleeps with the TV on all night. turn that TV off, be in a dark room. You know, those things actually help your brain as well. And I think this is the last one, manage your stress. We have done so many different studies where we have found that people who report higher levels of stress, whether it's being treated unfairly, or, you know, just feeling like your life is uncontrollable and overwhelming. People who report high on those types of things have a faster rate of cognitive decline. And so sometimes you can't always control how somebody treats you, right? But you can control how you respond, right? So it's about managing the stress that comes into your life. That's definitely gonna help your brain. And I just want to end with this part here. I'm on this Global Council for Brain Health, and we came up with the 6 pillars of brain health, and it's based on the research that's in the field, and I've already talked to you about the different ones, right? It's be social, engage your brain, manage stress, ongoing exercise, restorative sleep, and eating right. You know, so these are all the steps that you can take. So set a goal, identify a specific action that you want to take, find something fun, choose what you enjoy, because you're not going to do something if you don't like it. Repurpose some of your free time to make room for these new healthy habits, right? So when you have like 15 minutes, instead of being on TikTok, just get outside and walk, or pick up a book and read, right? And then involve friends or family and set common goals, because a lot of times when you have accountability, that's when these things work the best. So to conclude, there's been many advances in HIV management that have resulted in people living longer with HIV. And all those age-related comorbidities that I talked about, hypertension, diabetes, all the things that we know come with aging anyway, occurring in the context of HIV disease, make it challenging to separate aging from HIV complications. And we really need more research to understand the impact of HIV disparities, because as I told you, this is a disease that affects Black people more than anyone else. And so I talked about some of the protective factors for better brain health. These should be targeted to enhance healthy aging in people with HIV. I want to end with this slide because I really like it. I like the message, right? And we know what's happening right now in the government. And in fact, I have lost grants because I focus on equity. And I was fired from an NIH committee because of my background. But it doesn't matter. I'm going to keep going anyway.
Yes.
Yeah. Because, it's important, right? So health equity is when everyone has a fair and just opportunity for brain health. So these 4 little pictures tell you what health equity is. So first is inequality. So you have the 2 people under the tree, right? And they're trying to get the apples. But the apples are only coming to one person. The other person's like, where are my apples? So this is unequal access to opportunities. So then we say, okay, we're gonna make it equal. We're gonna give everybody the same thing. That's the second box. So then they distribute, they give everybody the same ladder so that they can reach the apples. But guess what? That guy over there still can't reach the apples, right? So giving everybody the same thing is not always the answer. So then we move to equity, where we give people what they need when they need. So we give this person a bigger ladder, so now they can reach the apples. But you can see they're still not getting as many apples, right? So equity that's not the only issue. It has to be justice. Justice is making the tree, putting the little rope so the tree goes all the way over so that the apples are evenly distributed. It's changing the system, right? We have to change the system if we want to have justice so that everyone has a fair and equal opportunity for brain health. And that's what I'm trying to do in my research, so that we all can live and thrive as we get older. So thank you so much for your attention and the great questions. Are there any more questions?
Yes.
Yes.
You mentioned the disparities that are within Blacks, African Americans. We know that CDC, when it was right before this administration, finally came out and said racism is a public health threat.
Right.
With that in mind, what is it that you might have seen in your research that is contributing to the disparities of individuals that are melanated?
Yeah, that's a great question. One of the bigger things that we're finding is that it was two parts. It's how people are being treated, so it's discrimination, right? We have a scale where we measure how frequently people receive unfair treatment from people, when you're shopping, when you're, at a restaurant, and we find that people who have more of these experiences have worse brain health. So it's something about being treated unfairly. We've also published that this is also related to a faster rate of death. So it's really, it's bad for you to be treated unfairly. But it's not just how people treat you, it's also the environments in which we live, the broader social context. So we are also measuring neighborhood factors like access to healthy foods, access to parks where you can walk and get, physical activity, the level of crime in your neighborhood. All of these things seem to also play a factor in your brain health. And you would think, well, that's outside, but your environment has a powerful effect on how you age, right? And so because of how society is, and Black people tend to live in disinvested neighborhoods, we're always surrounded by those kinds of disadvantages. So we're still, really trying to understand the many different layers, but it's these kinds of things that are contributing to the health disparity.
I just wanted to say thank you so much for sharing all of this information, because it's very important, but it's not always readily shared. So I appreciate you coming out and sharing it for sure, and especially the last slide that is so prophetic. Thank you.
Thank you, Gary.
And will we have a opportunity to get a copy of your slides so Jeff can maybe have this go out to
Sure.
our membership?
Yes.
Thank you.
Thank you, Doctor. I'm glad I took your information, yes.
Okay,
So I feel like you're right when it comes to how we're treated. We'll engage in care based on how we're treated, because older adults like myself, I'm 74, if I'm not treated properly, I tend to not attend. So I finally took a clinical trial. I engaged in a clinical trial.
Wow.
I know, it was difficult. but the thing was, I wanted to clear my system of Hep C. There was an opportunity to take part in a clinical trial for Harvoni for Hep C.
Okay.
And everything went fine, except when it came time for me to be compensated for my car fare. So I asked about it. I said, well, like there's compensation. I wasn't going there for the compensation. That's not what it was about. I was really trying to clear my system. But I was treated as if that's all I came for was the
Wow.
Metro card. And the nurse said to me, you ought to be glad that you're getting this medicine because it's very expensive.
Oh my God.
And I said, you ought to be glad you're taking my blood and using it for research.
Yeah.
So
I'm so glad you spoke up to her.
Yeah.
Because that's also a huge problem.
Right.
Why we don't have enough research on our people or, on things that affect us. Because the research community has treated people of color so poorly for so long, and even still they do. And when you go to these research studies, you don't see people of color in leadership positions, and that's a problem. So thank you for speaking up.
If we are silent about our pain, they will kill us and say that we enjoyed it. Zora Neale Hurston.
Yeah.
Final thing, could you share what your research question was for CEDA, and where was the aha moment for you who designed it?
Where was it? Or what was the research question?
What was your
Right.
research question?
My
You designed this study, and what was the aha moment that you'd like, whoa?
Yeah, my research question was to understand, is HIV a model for accelerated aging? Which I don't think it is. I think it's a model for accentuated aging, right? So people have all the same conditions, just more of them, but they're not necessarily happening earlier in life. Okay, that's what our studies showed. A lot of people with who had HIV in our study were actually doing better because everything was being managed. We recruited from the core center, so they were getting everything, diabetes, hypertension, mental health, all of these things were being controlled. Whereas in our people who didn't have HIV, some people hadn't been to the doctor in 10 years, right? So of course, HIV is not good for you, but the management of HIV seemed to be really helpful for people. So my aha moment though was, I think one of the things that we did was we did a brain imaging study too, to try to understand how HIV was affecting the brain. I didn't present those results, but a lot of people could not enroll into the imaging part because they had metal in their body. And we were surprised by that. But a lot of people are walking around with metal that they've never gotten removed. Either they worked in some kind of factory or it was, bullets.
Wow.
But they were not able to get into the scanner because you can't get into the scanner with anything metal. And so we wondered why that was the case, but it really showed me how much trauma our communities face and just live with it, right? And so there's a resilience to our people. So that to me was the aha moment. So now I'm really looking at resilience factors in my research. Like how are we able to go through all we go through and we're still standing?
All right. Can we have another round of applause for Dr. Lisa Barnes? Thank you for your food for thought, reflection, and action.